Atmospheric pollutants, A-level chemistry. So first we're going to have a look at two important definitions. And the first definition is a primary pollutant. And this is an air pollutant, so a gas, that is emitted directly from a source. So this means carbon dioxide is produced when we burn fossil fuels. So it is an air pollutant, a gas, that is emitted directly from a source like a fossil fuel. And then we have a secondary pollutant, and this is formed when a primary pollutant reacts in the atmosphere. So when primary pollutants react under sunlight, under UV radiation in the atmosphere, they form these secondary pollutants, for example, ozone. Now we're going to look at complete and incomplete combustion. Products of combustion of hydrocarbons vary depending on the oxygen availability. Complete combustion, which is hydrocarbons burning in excess oxygen. The hydrocarbon reacts with the oxygen in excess to produce carbon dioxide and water, but the products depend on this amount of oxygen. So incomplete combustion occurs when hydrocarbons burn with too little oxygen. This is when the hydrocarbon burns with too little oxygen to produce carbon monoxide, which is a carbon with one oxygen, plus this carbon dioxide, water, and carbon, which is also known as soot. So now we're going to have a look at pollutants in a summarized table. So our first pollutant is particulates, and these are small carbon particles. And these are produced by volcanoes, burning fuels, and burning coal. So when our fuels are produced when our fuels are burnt with incomplete combustion, soot is formed, and soot are carbon particles. So these can contribute to our particulates. And the major polluting effect of particulates is that they penetrate the human body, causing heart attacks and lung cancer. And another pollutant is volatile organic compounds. And volatile means they evaporate easily. And these come from plants and unburnt fuels from petrol engines. And volatile organic compounds cause photochemical smog, which can have damaging effects to human health as well as the planet's. And then we have carbon monoxide, which is a toxic gas. And this is formed by the incomplete combustion of hydrocarbons, as we saw on the last slide. And it's also produced by burning biomass. And biomass is organic matter used as a fuel, and organic meaning carbon containing. And the major polluting effect of carbon monoxide is that it's a toxic gas, and it also contributes to this photochemical smog, as well as the volatile organic compounds. Then we have carbon dioxide, and this is produced by the combustion of fossil fuels, again as we saw on the last slide. And this contributes to the greenhouse effect, which is damaging our Earth's atmosphere and contributing to climate change as well. And then we have nitrogen oxides, and these are produced by the combustion of fuels in power stations and vehicles. So this is when under the high heat of the vehicle's engine or in the power stations, nitrogen and oxygen bond at this high heat. So during this high temperature in our engine or our power station, the nitrogen and oxygen can bond. And this produces acid rain and photochemical smog. And then lastly, we have sulfur oxides. And this is produced from volcanoes and burning fuels which contain sulfur. So again, like the nitrogen oxides, we have this sulfur impurities in our fuel. So when we burn them at high temperatures, they can combine with the oxygen to form sulfur dioxide or sulfur trioxide. And these sulfur oxides are toxic gases that cause acid rain. The production of acid rain. Sulfur dioxide in the atmosphere reacts with the water, also in the atmosphere, to form sulfuric,
4 acid, and this is a weak acid. We can see this in the equation. Sulfur dioxide plus this water reacts to make this sulfuric 4 acid. However, sulfur dioxide is oxidized to create sulfur trioxide in the stratosphere. And this sulfur trioxide created when sulfur dioxide is oxidized reacts with water, also from the atmosphere, to form sulfuric 6 acid, which is a strong acid. So this is sulfur trioxide plus this water in a reaction to create this strong acid, sulfuric 6 acid, which contributes to acid rain.
So continuing the production of acid rain, we have nitrogen oxide and nitrogen dioxide. And these also react with water from the atmosphere, but they also react with oxygen. And this forms nitric 5 acid, and this is also a strong acid that can contribute to acid rain. So as you can see here in this equation, we have nitrogen oxide, and this reacts with water and oxygen to produce our strong acid. And you can also see when we have nitrogen dioxide, it also reacts with water and oxygen to produce this same strong acid. The only difference is that the amount of oxygen that these nitrogen oxides react with is different depending on the oxygen contained in the nitrogen.